Thanks a lot for joining me in this session. We are going to talk about machine learning. Okay, but first a few introduction details. So my name is Laurent Picard. As you can hear, I'm French. I live in Paris. You can follow me on Twitter at Picard Paris. I work for Google for something like 1 year and a half now. And in a previous life, I co-founded Bookin, and I was a pioneer in the ebook industry. So I was one of the makers of the first ebook device 20 years ago. And so it was a big brick of 1 kilogram, which was working, but was too early. But now you have ebook devices in all places. So as you can guess, I've done a lot of embedded development, a lot of software, and eventually I came to the cloud because devices got connected and so on. But I'd like to know more about you. So who is a developer in the audience? Yeah. Do we have data scientists? Raise your hand. So, shy? One. So I'm not a data scientist. I'm not an expert. So you will correct me, right, if I'm wrong, OK? Thank you. Do we have machine learning users? Actually, you all use machine learning without knowing it. You have assistants, I guess. You have assistants on your mobile phones or at home. And do we have cloud users? Are you using cloud services somehow in your solutions? OK. Roughly 15%. OK, cool. So I would like to start with this quote, famous quote from Arthur C. Clarke, because whenever I met machine learning solutions, my first impression was that it was like magic. And really, this quote reflects exactly the feeling. And what's cool is that years after, I still sometimes feel the magic, but obviously, it's not magic, right? It's, if you know, it's just technology. So my goal today is to show what you can do as a developer, because we are developers, what you can do with machine learning, and actually you can even build machine learning. Okay. But first, what's a conference? Okay, so a big shortcut, but that's human learning. What you have today, you have a bunch of slides, maybe some bullet points. So that's data. But what you're going to get out of it is information. So you're here to learn, right? Well, machine learning is exactly the same. As an input, you have some data. And then we want to extract information out of this data. Okay? How does it work, basically? So the experts have been trying for decades to so they've been trying to mimic the way they think our brain works. Okay, we're not sure, but it seems to work. How? So we're using a lot of different examples from real life, and as a result, we managed to solve actual problems as of today. So it works. We're not sure exactly how it works still, but we have tangible results. So I'm going to be using machine learning as a term. Actually, you should be, if I was a purist, I should be using deep learning, but it's so easy to use machine learning instead, and I think that's the term that will catch up with everyone. So I will say machine learning. Okay, so how does it work in practice? So you give examples. So if you want to make the difference between cats and dogs, you give many samples of cats and dogs, and it will train, it will create connections. So that's mathematical coefficients, actually, but it will create connections between different layers. That's a neural network. And what you say is, so you're telling the neural network the output that you're expecting. And so it will create connections. And when you're done with that, then you can use your model, and you can give it new pictures or new input, new data. And here, for instance, it is going to tell you there's a dog in this picture. Okay. Just an example, at Google, for the last few years, we've seen an exponential use of machine learning models. So those are the numbers of models that are used in projects. We have a big repository at Google, so those are the numbers of neural network models. And it's just the beginning, okay? So if we get the big picture, there are 3 ways we can benefit from machine learning today. So the legacy way, the hardcore machine learning, so data scientists, data engineers, they've been working on this field for decades. Really, I've met some people who worked for over 30 years on machine learning. So thanks to them, we have today a lot of theory, a lot of many algorithms, and they've been exploring a lot of stuff, and we have a lot of research papers. And also now, as of today, with the cloud, we have a lot of computing power. So this is why it's working today. A lot of research done before and computing power. But as developers, we can use today machine learning APIs. So those are existing models that we can use right away. You can use that in a couple of hours, and you can actually, in less than a day, integrate that into your solutions. And there's a new way. You see there's a big gap in between. 1 year ago, you had to be either an expert or a developer, but you could only use existing models, so maybe it wouldn't fit your needs. And so now there's a new technique called AutoML, where you can actually build your own neural networks without being an expert at all. And what I'm going to show you today is what you can do here as a developer, and what you can do now also with AutoML techniques. Okay, so I'm gonna use Google Cloud machine learning API solutions, but it's just as an illustration. Of course, most public clouds offer these services, and also some dedicated companies work on this field or this field. Okay, but my goal is for you to understand that you can actually do machine learning today. So let's start with the APIs. So we call them building blocks. Building blocks are like Lego bricks. You can actually take one, you can plug it into your system, and sometimes you can even plug a few of them all together. So they are ready to use models, and we have a family of 6 of them. I think we cover pretty much everything. So as an input, you remember the data that you give. You can input text, images, videos, and speech. And as an output, you get information about images, videos, text. But you can also transform this data. You can translate it, or you can convert it from speech to text and from text to speech. Okay, so I'm going to give you a few examples, visual or actual examples of this. And I live in Paris, and I also like Tolkien, so you will have a few samples about Tolkien. So the Vision API, so that's my favorite one, but for personal reasons. 25 years ago, I worked a lot on image processing. So as a beginner, I was trying to understand what was in a picture. And the technique at the time was to detect edges. So for instance, in a face, we wanted to detect edges or edges of different objects. So we were using convolution filters and so on. So it worked. You could detect edges, but so what? Then you had to understand what the edges were and if they were belonging to the same object or not. So it was pretty limited. It was starting to work, but then when you had new pictures, it stopped to work. Okay, so it was pretty frustrating. As of today, with machine learning, you can actually solve that. So a few examples. You can detect landmarks. So if I live in Paris, I give the API this picture, it will tell me, okay, this is a picture about Paris. Okay, so I get a description. I get a bounding box, so this is telling me, here is the area that is about Paris. And it's also giving me a location, a GPS location, so I know exactly where it is. But it's no big deal. Anyone here could tell, okay, this is the Eiffel Tower in Paris. So a bit harder. So this picture still has an Eiffel Tower, but it's not Paris, it's Las Vegas, okay, where they're trying to reproduce a small Paris there. So the Vision API tells me that, okay, this is not Paris, but this is the Paris Hotel and Casino. And so it also gives me the right location. And I can also find the pictures that are the actual picture I took, even though I cropped it. And likewise, I can also get pictures that are similar. So I will mostly get pictures from Las Vegas because there's a lot of light during the nights. Okay. But I live in Paris, and if I see that, I will tell you right away in 1/10 of a second, okay, this is not Paris. Too much light, it's not like that. So I tried to tweak the system, and I took a picture from Las Vegas, but I changed it. So I zoomed in, cropped it, I skewed it, I flipped, it's flipped. And so with this picture, anyone from Paris in less than 2 seconds would say, yeah, this is Paris, yeah, no problem. But actually, this is still Las Vegas. And the Vision API is not fooled here. It's also telling me this is Las Vegas. So the machine here is beating me. I would need more than 1 second to say, wait a second, actually, there's nothing here below the Eiffel Tower. And so here, this is an example where we are near or above human detection. Okay? It's a precise example. But likewise, you can, so it's a picture from New Zealand where the Lord of the Rings was shot. You can give it a picture, and it will tell you what's in the picture with labels. So here in this picture, it's about nature. There's a tree, there's grass, there's a sky. It's a photography. Yeah, everything is right. It will also detect text blocks. So for instance, here, it's able to detect here that there's a sign, and it's giving me the text. So it's not perfect. The sign is, okay, for us, it's pretty easy to read. It's a fancy font. But there are small stresses above the vowels. And so here, it's making a mistake. So almost everything is correct, but there should be a space between except and all. So you see the limit, but I took this example on purpose. It's slightly hard, but it's just a matter of time. With time, it will not make this mistake anymore. Okay? So likewise, it's able to tell you whether there are faces in the picture. So I took this 3D rendition of Gollum. So it's able to tell me, okay, there's a face, and here is the close-up of the face. Here are the different points, the eyes, the nose, and everything. And likewise, it's able to detect emotions. So here, it's telling me, okay, this face is likely to be angry. And as we know, Gollum is most of the time angry, so that's also correct. Okay, so you see here the JSON response that we can use. We have the position in 3 dimensions of the face, and we have the likelihood of the different emotions. And also, we can know whether the picture is blurred, whether the face is wearing something on top of the head, and whether the picture is underexposed. Okay? So could be useful. And likewise, if there is something famous in the picture, a person or an object or a place, it's going to give me the entities. So this time, I took a pretty rare picture. I had never seen it before. It's been used only by Spanish newspapers. And so this is Tolkien in a forest. And it's able to recognize the picture, even though I cropped it also. And so it's telling me that this picture is about Tolkien, maybe the Lord of the Rings, and this is correct. And it's able to tell me where my picture was taken from. And that's the Spanish newspaper. Okay. So as I told you, it's an API. So you can do web requests over the web, and you will get the JSON response. But maybe, and you will find Java here, you will find one of your favorite languages here. So you can actually use open source client libraries, and you should, because it's a lot easier to process. So for instance, here, the only thing you have to do is a wrapper around the API. You create a client, you provide the content, you call face detection, and then you have the results, okay, that you can process immediately in a few lines. So this is where I think the cloud services are pretty cool to use with client libraries. Okay. So let's do a live demo about this. It was a bit static. So I'm going to use pictures that I took, okay? Oh, okay, did you recognize something? So this first picture was taken yesterday evening, just around the corner over there. So it's telling me, of course, I removed, every time I remove the metadata, we are not using the metadata by default. We can if you tell us to do so, for instance, the GPS, but here there's no metadata in the picture. So it's telling me, okay, it was shot at night, there's a sky, a monument, a tower, a column, and an obelisk. And the main entities are tower and obelisk, which is correct, okay? So I shouldn't be disappointed, and I'm not sure this place is famous, not yet. So this is why I guess we don't find it a lot on the web, so this is why I'm not being told where it is and the name of these monuments. Right? So let's try something else. This is the picture I took this morning at the keynote. So as you can see, I was over there, and it's telling me it's a seminar, a convention, an auditorium, and there's an audience, so everything is correct. So the cool thing is that you can imagine about indexing everything. If you have a lot of pictures, it's often a burden to browse your pictures and try to classify them. You can actually find something in your pictures with something like that. And likewise, so yeah, and it's even able, you see, to tell me what's written on the slide here. I want to say as close to the edge. So that was a quote from the keynote in the slides. So then those are pictures I took from the web, but I cropped them, also I changed them. Okay, so there's a face here. Okay, and so I don't know who this person is. Okay, so it's telling me that it's a spokesperson. Not exactly, but mainly because there's a mic, I guess. So like here, so this person maybe was not speaking or spoke, but then pledged allegiance to something. And who is this person? This is Viorica, yeah, Dancila, is it correct? Okay. So now I know who this person is thanks to that. And last example. So this is a picture I took on purpose. Just to show you also, I can know the nature of the picture. So here it's telling me that it's possibly a violent picture. So maybe I don't want to show this picture to my kids, okay? So a few examples with pictures I took, but what I propose you to do is to do it live with your smartphones. So you can get your smartphones connected, and we're going to try that live with your own pictures or your own selfies, okay? Okay, so I invite you to get connected to this URL, bit.ly/vdcluj18, or you can also scan the QR code. Okay. I'll give you a moment. Yeah, can you connect? VD for Vox Days, Cluj 18. Yeah? Okay, so you should reach something like that. And then I'm going to move, so it will stay here if you want to connect a bit later. Okay, so let's move to step 1. If you refresh, then you can enter a nickname, and then it's going to use your camera. So if you're not supposed to be in this room, maybe don't do it, because we might see you on the screen, okay, and on the web. Okay, so you can take a few selfies and try to express emotions. So be happy, be sad, be angry, and we'll see the results. So I'll be trying with you. Okay, so that was supposed to be angry. So yeah, I forgot to tell you something. Okay. How does it work? Okay, I will tell you after. So let's go on. Let's try to be sad. Okay. And happy to finish. So let's see what we got. A few of you should be over here. Yeah, it's coming. Okay. So those are the latest pictures that each of us sent. Okay. So we have samples. So let's see who's been angry. Only me. Okay. Who's been sad? 2 of us. Okay. Who's been surprised? Only me. Okay. And who's happy? Cool. Okay. So you're happy, audience. Cool. So you see, with a few lines, that's actually what you saw. It's very easy to find the faces and get the emotions. OK, so how does it work? So I'm just using cloud services, and that's generic principles. So on the right, on the right, I created buckets. So buckets are like folders in the cloud. Really, folders in the cloud. I can push my content over there. So whenever I move to step 1, you could take a picture and upload it here. And what it does here is I created 3 functions. So I actually have functions that I just deployed like that and nothing else. I don't care about servers. This is called a serverless architecture. And what it does here, so whenever there's a picture here, it automatically calls this function, which will call the Vision API to detect whether there's a face and the emotions. I store the results here. So here I have JPEGs, for instance, and here I have JSON files. And whenever I receive something, then I can composite something. So I'm adding the mustache over the face. So if you took a picture of 2 or 3 of you, I'm adding 3 mustaches in this step. And then it will store the result here and will trigger a last function and where I will crop the largest face. So the face with the most pixels in it. And the result that you could see on the screen are stored here. So you see? So very easy to do. And this is a demo that I can deploy in 20 minutes from scratch. OK? So we've seen it worked pretty well. Thank you for your participation. Now, the Video Intelligence API. So you can imagine it's pretty much the same. You can do almost the same, but you have an additional dimension, right? You have time. So what you can actually do is get all the different sequences within your video, and then for each sequence, you will know what it is about. So it's better to show you an example. Oh, I forgot something. OK, let me invite some guests. That way you will have someone from your country, a famous person. Yeah, I'm going too fast. I'm sorry, I forgot something. OK, I will not go back. OK, so I wanted to show you this example with the video API. So this video is 1 minute and a half. And here are the labels I get from the video. So for instance, it's telling me that there's a Milky Way here. OK. I don't have the sound. OK. A bit below, or here, yeah, there are human faces, most of it, most surely, you can see. And here I have a polar bear in the video. So you see? So like pictures, but you can actually also index your videos thanks to that. Okay. So I forgot one thing just before, because I'm going too fast. I added a few guests. And if I show you the result, OK, so all the happy people. Here, I've added the zombie picture. And as you remember, it's classified as possibly violent. So what I'm doing in my pipeline, if there's something violent or that I shouldn't do, I'm blurring it. OK, so this is how it works. And do we have your... Oh, OK, someone sent a picture from his laptop, maybe? I don't see your prime minister. Is she somewhere? Yeah, she is here. OK. Okay. So now, we've seen pictures and videos, but you can work on text, and basically text is what we process the most easily on computers, and even in our brains. It's not exactly text, but our reasoning is most of the time on words, right? So text is really at the core of everything. And so it's called the Natural Language API, so maybe you've heard about NLP, Natural Language Processing. So this is basically what it's about. And so this time, I'm using a sentence about Tolkien. So the API can tell me that it's English, and is going also to tell me all the different relationships between the different items, every type, but also the punctuation. And one thing that I like as a developer is that I get the lemmas. So here, for instance, I know that was relates to the verb to be. So it allows me to work in a canonical way. If I want to detect some forms, then I can focus on the canonical word. Okay. Then if I take the same sentence, I can, like in pictures, I can recognize entities. So with the same sentence, I'm going to get 3 different groups. The first one in red, so for instance, Tolkien is recognized as a person. And I'm getting an ID, an identifier for this person. It's actually the same ID as when Tolkien was described in the picture before. So pretty cool to know if we're talking about something in different medias, right? Likewise, British so is mapped to the location class, and so it's related to United Kingdom. And then the 3 books at the end are each recognized as a work of art, and also I get an ID for each of them. So it works really well. Then, like for pictures, it's able to analyze the sentiments. So not the emotions, but it's able to tell me whether something is positive or negative. So I took 2 example reviews of The Hobbit, an old one from the New York Times, and a recent one that is negative from Goodreads. So Goodreads is a social network for book lovers. The New York Times one was very positive. So the result I get different sentences with a rating between -1 and +1. And here, the 3 sentences are negative, and they come from Pauline's review. And at the top, the 3 positive sentences come from the New York Times. So it also works well. Okay, and last, you can classify the content. So you can know whether you should sort out your text in some category or another. So here, the sentence should be classified under books and literature, and it's 97% sure about it. So also, that's correct. Okay? So an example of the client API. So like before, you create a client, you provide the content, and you call the function analyze sentiments, and then you can use it right away. So if you're interested in business use cases, so there's this British company called Ocado. It's a big retailer in the UK, and they have a team of data scientists. So they know how to do machine learning. But what they realized is that it was easier and more efficient to use this API to actually analyze the text that they're getting from their customers. So for instance, every day they get thousands of emails from their customers. And one obvious thing you can think about is they can analyze, for instance, negative emails. And whenever there's a hungry customer, then maybe you should focus on him or her. So they are treating negative input in priority. So they are more efficient with the same teams, and they can focus on what is important. And of course, the positive feedback is important too, but you can wait for 1 month to process everything, right? Or if you want to provide that to the marketing, for instance, you're not in a hurry to process positive feedback. Okay. They communicate quite a lot about it. They explain how they improve their customer service. So if you look for Ocado and machine learning, you will find some articles. Then still on text translation API, so I won't get into many details because I'm sure all of you have used it somehow. So that's basically Google Translate here. So it works from over 100 languages to over 100 languages. So that's thousands of different combinations. But maybe one example I wanted to give you is that 3 years ago, so I was not working for Google, but I was using Google Translate as a simple user. And so I was translating French, English, but also other languages most often. And I noticed something at the time, that the quality improved quite a lot from one day to the other. So there was a big quality jump. And since I work at Google, I got the explanation. So what happened a couple of years ago is that the team switched from a mostly statistical model to a purely machine learning model. And this is where this is where the translation got a lot closer to the human possible translation. So as I told you, with pictures, we can do today something that we couldn't 20 years ago. So likewise with translation, this is something pretty new from a couple of years. So here, same sample, but I have more comments than actual code. There are only 2 lines. You create a client, you call translate, and you have the translation immediately. Okay. Business use case, Airbnb, 60% of their users don't speak the same language. So of course, it's a limitation, and they are virtually translating everything. And thanks to that, it's a reason, part of the reason of their success. Okay. So, like before, I improved a little bit my demo, and I propose you to try that live. Okay. So what I did is, into my backend, I added 2 calls. So so you're going to be able to text me, right, from your smartphone. If it's not English, I will translate it to English, and then I will pass it through natural language analysis. Okay. So let's move to step 2, and if you go to the next step, yeah, you can text anything. So I'm going to write something in French. Okay, so feel free to express any emotion, to talk about something or someone famous, and we will try to see if in a few seconds I can understand what you've been talking about. Okay, let me add a few more samples in English. So I really love raspberries and hate watermelons. And we have some Chinese and some Japanese here. So okay. Okay, let's see the different messages that you sent. 29, 30, okay, so it's coming. So, okay, es ist nicht schwer, okay, some German. What is HI as a language? Oh, it has not been so here it has not been translated. So, okay, so it didn't work. So we have Romanian, Hungarian. Okay, so it's almost some French. There's a Romanian. Okay, my sentence. Okay, ich bin hier. Some Spanish. So those were my sentences. Romanian, Hungarian. So I can get a good idea of who is in the audience. A lot of Romanians. Okay, so those are the translations. Then what are the entities? So someone talked about the prime minister. So I don't remember the sentence. I talked about Cluj, someone talked about Germany, and someone talked about Niccolo Machiavelli. So I guess it's that's the English name. Okay, Niccolo Machiavelli. Presentation conference rooms. So these are the labels we talked about, and 10 persons have been quoted. And here are the sentiments. Oh, thank you. You're very positive. I like charm. Okay, your focus is great. School. So this is my sentence. Nice to see you. Alas there. Okay, thank you. I love Apple, so very positive. I love Germany. So where is your prime minister quoted? Hello. So now we are in the neutral sentences. Winter's coming. It could be negative, but you would have to understand the second sense, you know. So, for instance, as of today, it doesn't understand sarcasm, right? If I'm being sarcastic, it will not get it, not yet. But with time, with context, it will learn. Yeah. Am I nervous? Okay. Machiavelli is very loud. Okay. And who's been negative? Okay. Okay. So this is where you talked about your prime minister. Okay. So it works. Okay. It's not perfect, but in a few seconds, you can actually process data and understand a lot of things, right? So let's go on. So now, let's see what you can do with speech. So there's a first API, speech to text, okay? So this is the basic brick of all assistants. You can now say, okay, Gulexi, for instance, and the assistant will talk back to you, right? So you can have a conversation with an assistant because first it's able to understand what you're saying because it's transcribed into text, okay? So the cool thing is that it's real time. It's also robust to noise. So for instance, it has been trained on a lot of different phone conversations. And you can even improve it by providing some dictionary. For instance, if you're working in a hospital with a lot of medical terms, then it will improve the recognition of the different words. Okay? And like before, you can provide your speeches, and you're able to index the speeches and get the location of every word in your audio files. Okay, so business example, like Airbnb. Azar is a matchmaking app developing company, publisher. So they try to connect people all over the world and see whether they can meet their soulmates. So they are translating everything, but on top of that, they are transcribing speech to text and then translating. So also a use case. So a live demo. So I will actually, I didn't integrate that in my demo, but I'm going to use something, a browser with this. Use your microphone, yes. What is the temperature in Cluj-Napoca? Okay, and I'm supposed to get. So as you could see, it's actually the speech to text in action. So it's understanding in real time what I'm saying, and sometimes when I start to pronounce a word, it will misunderstand it because it's exactly the way it works with us. It's with time we understand something, but when the sentence is finished, most of the time we have understood everything and correctly. But in between, maybe you could understand something wrong. Let me try something else. So, what's the temperature in Paris? Okay, sorry, started to. What is the temperature in Paris? Oh, okay, so I will stay here. It's actually a lot colder in Paris. I didn't know. I thought it was higher. Okay, so that was the speech to text, and now the opposite. Text to speech. So text to speech is not new. If you remember, I told you I was working around 2000 on ebook devices, and I actually worked with text to speech at the time. I integrated a book reading application on this device. It was working, so I was quite proud about it. You could press a button, and it would read the book aloud. So it would, and each word was synchronized. But so I was very happy. We launched the firmware update, and nobody used it. So it's not because it wasn't working. It's because it was like a robot talking to you. Yeah, Alice in Wonderland, and so that was like that at the time. But as you could see, as of today, it's very natural. And there's this breakthrough from DeepMind. So maybe you know DeepMind because they managed to beat the world champion for Go. So DeepMind, with machine learning, it's very elaborate. They managed to actually reproduce human voice, but without knowing anything about human voice. So 20 years ago, what the experts tried to do is to work on phonemes. So they try to mimic the way we actually transcribe text in voice with phonemes. Some companies even specialize on working on half phonemes and a lot of statistics. It was okay, so eventually it converged to something more pleasant. But with this machine learning model, it's really like a human voice, very, very human-like. So even though I told you the Vision API is my favorite, have a look at WaveNet. It's actually what's embedded in current assistants. Let me give you this example. You maybe will not hear it well. Okay, just to tell you, so we've been playing this game with my teammates. We have samples of the actual voices that got recorded, and we have the same samples which have been generated by WaveNet. And 50% of the time we were wrong. We couldn't detect it. So it means it's almost like the actual human voice. So I think you didn't hear it well, but the first one was actually the WaveNet generated sample. Okay, so it's really groundbreaking, this technology. I wish the Vision API would be even stronger than that, but this one, I have to admit, is the best as of today, the closest to the human detection or recognition. Okay, so let's move to the second part, AutoML. So what we've seen so far is that you can use an API and you will get as much insight as possible from what you provide. But in some cases, it won't work. It will be too generic, right? So what you can do is provide your own samples and customize the model for you. So here you provide the samples. You launch a training, so you can even not be a developer. Anyone can use it. So it will launch a training and will give you a first result. And then maybe you will have to cycle a little bit between providing more samples or more quality and training. And then when you're done, you have an API in the cloud that you can use right away. So it's exactly like before, but this time this is your API. You are going to build a neural network without knowing how it works. Okay, so this is pretty new. It's less than 1 year ago. This is a family that is going to expand. You are going to see that everywhere in all public clouds. And as of today, we are able to process images and text as data, and we will provide you, or you will actually get your custom classifications or your custom translations. Okay? So let me show you an example. Still with the AutoML Vision API. So if we use these two pictures with the Vision API, the results that we're going to get are almost the same, okay? Because why? Because it's clouds in the sky, okay? So it's almost the same results. But what if I want to recognize exactly the type of clouds that they are, the cirrus and the alto cumulus? Then I can use AutoML Vision here. So this is a demo that was done by Sarah Robinson. So she's a teammate in New York. So she gave all these samples with labels. Then she launched a training, and she launched 2 trainings. The first one of 1 hour, and she got a first model with this precision. And then she did it again for 3 hours. And even with 3 hours of training, she's starting to get something interesting. Here's a visualization. So when you want to evaluate your model, you can have a look at the confusion matrix. So in the diagonal is the results that are working. So for instance, here, we are able to to detect the cumulonimbus pretty well on the data that we provided. But we are pretty bad at detecting the altostratus, right? Because it's misdetected with everything else now and then, okay? So it means we have to provide maybe more samples, more different samples, or better quality samples, okay? So I tried Sarah's model. So this is a picture I took myself, and here it works. It's detected as a commerce, okay? As business examples, there are already, so it's in beta right now, but there are already companies using that in production. There's one I liked pretty well, ZSL, because I met the company in London 1 month ago. So let me just show you quickly. Yeah. Okay, so ZSL is the Zoological Society of London. So it's a charity, and they try to improve biology conservation all over the world. So their teams are putting cameras in white forests, and whenever there's a movement or heat detection, it will take a picture. So they put cameras, and they leave the cameras for 6 months in the forest. So it's going to take, in 6 months, up to 500,000 pictures. Well, that's a lot for one camera. And then 6 months after, they get the cameras back. And up until now, what they did, they had 6 months of processing for each camera to label each picture, to say, okay, here in this picture, this is this kind of tiger, and everything. So you can see. And they're using AutoML vision, and they can benefit from all the previous years of labeling that they did so far. And now they can automatically process the new pictures. And they're able to, so you see here, all the different, can you see? Yeah. All the different species that they can recognize. The Malay weasel, I don't know most of them. The Malay porcupine in this example. And so thanks to that, they went from 6 months of processing to days. So it's a lot. And you can imagine they are saving months of work, and they have results as a few days after they get the pictures in their office. Okay? So, like before, I was a little bit tempted to integrate that into my demo, so I did so. So this is pretty new. I just tested it once last week, so this is going to be the second time with you. So what I did is, you know, I've been detected your faces in your selfies. So what I did is to try to detect new expressions, new emotions. Okay, so I trained the model, and I'm trying to detect whether you're going to stick out your tongue, okay, whether you're going to yawn, or whether you're sleeping. I want to know if you're a good audience or if I'm boring, okay? So let's move, if you take again your smartphones, I'm going to move to step 1 again, but with AutoML. And we're going to try to detect whether you're sticking out your tongue, yawning, or sleeping. So for instance, I'm going to, yeah, I have this sample. So I didn't use Albert Einstein in my training. So it's a new picture for it. I'm going to invite Albert. Yeah, I did it already as a guest before, so I replaced the picture. And now, up to you. So try to, oh, sorry. Okay. So you can try 3 emotions. So sleeping. Sleeping is pretty easy, I hope. Okay. Let's try yawning. So it's contagious, you know. So if I yawn, you should all yawn. Okay, the sound might help. You can try a few times, and likewise, let's stick out. Okay. So It works. Thank you, thank you. So last week it didn't work that well, but I provided more samples. So here, everything is correct. Everyone is sticking out here or her tongue. Here, Alasdair tried to do two things, sticking out his tongue while sleeping, so it detected the tongue, but I think it's the feature that is the most easy to detect. So let's see who's been yawning. Nobody. Okay, so it didn't work well, but that's the most difficult one for me. Okay, and sleeping. Okay, a few of you have been sleeping. Okay, let's wake up. Okay, so you see, I spent one day on that. Half a day last week with the first training, first sampling, and half a day this week where I flipped the pictures, I rotated them, so I provided more samples. So I need to improve that, but I will check the expressions that have not been detected. I don't know how many, but it's starting to work pretty well. So, and I'm not a data scientist, and all I had to do is provide samples and give labels. Okay. So it's better. How much time do we have? Yeah, it's time to. So I will publish my slides, but you have to know a few things if you're not an expert. There are metrics about the precision and the recall of your model. Okay, so maybe those are terms you've heard before. If you want to understand how a model works, you have to know about false positives and false negatives. Okay. Okay, basically, the model precisions is the quality of your model, right? You don't want to get bad results. And at the opposite, the model recall shows the quantity of results that you can get. Okay. And you maybe you will use these two metrics. In some cases, you want quality, and in some other cases, if you are doing a search, like who is sleeping, then maybe I should favorize the recall. I want more results. Okay. Okay. I will let you see that in my slides when they're published. If you want to do more machine learning, then there's a full ecosystem that you can use. There are many different frameworks. One of them is TensorFlow, and then you're going to be specialized. With TensorFlow, you can actually build and design your neural network and launch the training on your laptop. And eventually, like in the examples before, you don't want to spend days or weeks to train on your laptop, then you will do the training in the cloud. Okay. As an indication, as of today, yeah, TensorFlow is the machine learning repo that is the most popular by far on GitHub. You have other ecosystems or frameworks like Keras or PyTorch. Okay, so it's up to you. Have a look. It depends on what you want to do. But it's up to your imagination. If you want to be an expert, you can spend the next decades to focus on that and do a lot. Okay. So here are the pointers for the APIs. You can try most of them directly on your browser, like I did when I talked or when I drag and drop pictures. Okay. And that's it for me. So I try to show you that as a developer, you can almost do like experts, but you can do a lot by using APIs and also by developing your own models. So I hope it was a good overview for you, and above everything else, I hope it gave you a few ideas. Feel free to ping me on Twitter or to send me feedback with this link. I'm hungry for feedback, how to improve that and so on. So thanks a lot for having me today. Thank you.